Hi guys, so in this video we're going to go through something called Frullani integrals. They're sort of a general sort of form of an integral that you can sometimes get that has a really standard nice result that we can sort of look at. So first of all, what's a sort of good example that can be solved using sort of a standard Frullani integral method? Well, something like this. So inverse tan of e to the minus ax plus, actually it's minus inverse tan of e to the minus bx divided by x dx. This is something that's quite nasty. It almost looks like there might not be a nice number that this comes out to be, but believe me, it is a really nice number. I think it's pi upon 4. Ln beta over alpha, but we'll be able to sort of check this out later on and sort of verify this. So first of all, what is this standard form? Well, it's going to be any integral in this form. So any integral in this form is going to have a really standard nice result. So first of all, realize that, well, this in itself is like an integral. So it's like I'm evaluating it at A and then I'm evaluating it at B. So you could say put a tx here divided by x, and well, we're evaluating it first at A and then at B. And well, how could I write this as an integral? Well, this is the integral of this thing differentiated. And the nice thing about this is the x disappears because of the chain rule. So we can then put the bounds in like so. Now, because this is y simple, in other words, the point on the plane is it's going from A to B, which are constants, and it's going from 0 to infinity, which are constant. So we consider it y and x simple. We can switch these, and I know we've used t instead of a y, but the same sort of applies. So we get an integral from 0 to infinity. Actually, we're switching them, so we get from b to a. We get from 0 to infinity. Now we get f prime of x dx dt. Okay, well, integrating this, we get pretty much the exact same thing. But this time we're evaluating we're evaluating the x, and our division is t because we integrate with respect to x. Okay, well, putting in infinity and putting in 0, this t is just going to disappear. It doesn't really matter what value this is going to be. So we're going to get f of infinity minus f of 0 divided by t dt. Because this on top is a constant, we can just evaluate this final bit. So you get f of infinity minus f of 0 multiplied by this integral evaluated, which is just going to be ln of t. And well, we get the nice result, f of infinity minus f of 0. It's going to be ln of a minus ln of b, or in other words, ln of a over b. Now, most of the time it's actually written in a more nice form, because usually this thing is 0. This thing is usually going to be the one that's 0. So usually we write it in this form, like this. So times through by -1 in this one. So that means I need to times through by -1 on that, which means I just flip the fraction. And this is our nice result. So if we go up to our original integral up the top here, well, what's our function? Well, clearly f of x is equal to inverse tan e to the minus x, like so, because this is f of ax and this is f of bx. So this integral, I'm going to call this I is equal to f of infinity, so the lim, actually we'll do 0 first, of course. So inverse tan of e to the minus 0, which is just inverse tan of 1, minus f of infinity, but that's just inverse tan of 0, and then we're multiplying by ln of b over a. And well, inverse tan of 1 is pi upon 4. So this really nice result follows. This can be applied to loads of different ones. I think the simplest case is 0 to infinity of e to the minus ax minus e to the minus bx over x dx, which you can sort of give yourself as an exercise. You can also be really creative with these integrals. You can put any sort of function here, as long as when you put in infinity and 0 it comes out to be a nice number. So unfortunately things like 1 over x just aren't going to work in this case. However, there are a lot of nice functions that this does work for, so you can make some quite cool integrals that you can send to your sort of friends and give it as a challenge. Say, well, prove this is equal to e times the ln of b over a or something like that. But yeah, thanks for watching.